Okay, so this is section 9.5. I had to think about it. For section 9.5, we're talking about arcs and how they correspond to tangents and secants and the angles that they form. So there are some basic things that you need to learn and some basic formulas that are going to come out. So I have all the lovely words written here that you're going to have to copy down. Good to know. It's the difference between you highlighting it in your book and then going and copying it, and you just writing it from off the board and then going and copying it. It's first of all, if you write it off the board, then you're only writing it one time instead of writing it twice or highlighting and writing it. So it's just writing it one time. I'm not going to make you go put it in your postulates and theorems or anything, because that's pretty much stuff you've already memorized. And this is stuff you're going to have to use every once in a while, not all the time. You might have to go back and recall, but probably not going to be something that's an all the time kind of thing like some of that stuff from the earlier stuff was. Second of all, if you just write it off the board, you'll kind of see how to condense it before you might want to put it in that. So I'll have all the pretty words there, I'll explain it, and then I'll make it a shortcut form so that if you want to write the shortcut form in there, you can. Just make sure the picture goes with the shortcut form as well, because the picture is explained in the shortcut form. So let's get to work. One of the big theorems is if two chords intersect inside a circle, which is what I've got, two chords intersecting, they don't have to be a diameter, they just got to intersect inside the circle, then the angle formed is half the sum of the intercepted arcs. Now they use this word, I know you know what intersect means, so I'm not too worried about that, but they use this word intercept a lot. And what they're meaning is the arc that's formed, that's the one that's intercepted. Not intersected because it doesn't go into it, it doesn't cross it or anything, it creates it by those intercepted lines. So the intercepted arcs. In other words, when I have this picture here, if I want to know what this angle is, angle ACB, I can find this angle by looking at this arc. Okay, it's not a very pretty drawn line. This arc and this arc. In fact, what I do is I take the measure of this arc and the measure of that arc, add them up and divide by 2. In other words, take the average, and that'll give me what that angle is. Down here, if a tangent and a chord intersect, and then the angle they form is half the measure of the intercepted arc. So here is my tangent right here, and here is my chord. And when they intersect, then this angle right here will be half of whatever this arc is. Well, the arc keeps on going around, but you get the point. It's half of that arc. So in other words, the measure of angle ABC is equal to half of that arc. If a tangent and a secant, or two secants or two tangents, intersect in a point outside the circle, like down here where C is, then the measure of the formed angle is half the difference. So angle C is half the difference of these two arcs. Now they're using the word difference instead of sum. So the measure of angle C is equal to 1/2 the measure of AD minus BD. Technically, it's the absolute value, half the measure of the absolute value of those. But I figure you'll know to put the big arc first and the little arc second. So it'll all be okay. Okay, so those were the major things. So go ahead and write down the words if you need to. I'll give you a second. Okay, seconds up. You can always pause the tape. But the formula formulas you're going to need to keep in your mind. So I'm going to leave them written up here for a bit because I'm going to need to keep referring back to them. That's one of the formulas for that one, but there is another one. So this one goes with this picture, but I'm going to stick another picture here real quick. My other picture is going to look like this. It's going to have the same basic idea. We have the A, the B, the C, the D, the E. And it says the measure of angle C right here is equal to 1/2 the measure of AD minus the measure of BE. So when you have two tangents, it'll look like that. And when you have a tangent and a secant, when you have two secants, it'll look like that. When you have a tangent and a secant, it'll look like this. And we'll show you two tangents in a minute. Okay, so those are the basics, the information. Now let's do some playing around. These are drawings adapted from, let me try to get that flash out. These are drawings adapted from the classroom exercises on page 375. Some of them I had to flip the picture on so that I could actually draw it in this small of a space, but that's where I get these from. So for problem number 1, they want us to find x. I'm dealing with a tangent and a chord in this case, or a tangent and a secant. So when I'm dealing with a tangent and a chord, it's right here. When I'm dealing with a tangent and a secant, it's down here. Tangent and a secant. The difference is where they intersect at. So if it intersects on the circle, that's this one. And if it intersects outside the circle, that's this one. Inside the circle, on the circle, outside the circle. So in number 1's case, it intersects where? On the circle. So that means we're going to have to use this one. So the measure of our angle is equal to 1/2 of the arc. So that means the measure of our angle equals 1/2 the measure of our arc. And I don't need to know what these things are. So I don't need letters up there. I just know that the measure of my angle is 30 degrees. So I'll put my 30 here. Equals 1/2, and the measure of the arc is what we're looking for. That's x. That's pretty simple, plugging stuff in. So now I get 30 is equal to 1/2 x. I can multiply both sides by 2 and get that x is equal to 60. So it's going to be 60 degrees for number 1. Hey, look, I'm right. Just saying. It's not as hard as you want it to be, I promise. For number 2, we have an x and a y, a 120 for that arc and a 20 for that arc. Does it intersect inside the circle, on the circle, or outside the circle? That is correct. It is inside the circle. So that means we're going to have to use this one, which means it's going to have to look like this. So that would mean that the measure of my angle, in this case, I'm going to use the measure of angle X, is going to equal 1/2 the measure of AB, which I'm going to say is 120, plus the measure of DE, which I'm going to say is 20 degrees. Now, X, because I want to make sure you got this part right, X is the one that forms the 120 and the 20 degrees. I can't do this with Y because that's not what forms those angles. So you have to make sure that you use the correct stuff. Okay, so now we're back to the measure of angle X is going to equal 1/2. 120 plus 20 is 140. So the measure of angle X is going to equal to 70 degrees. And if X is 70 degrees, then Y must be 180 minus that 70 because of the whole linear pair stuff, which makes Y 110 degrees. Hey, look, I'm right. So you try number 3, 4, 5, and 6. Doing the same things. Let's see how you do. Go ahead and pause the tape. If you'd rather look at it in your book than try to figure out what this says up here, that's fine. Go ahead and try it. Okay, so we are back. The answer to number 3 is 30 because we know that 70, that 1/2 of 70 plus X is going to have to equal 50 because that's what our angle is, and these two have to add up and take half of it to get your angle. So 50 equals you want me to distribute it? You might. 50 equals 1/2 of 70 plus 1/2 X. Half of 70 is 35. So up here, 50 equals 35 plus 1/2 X. Subtract 35 from both sides. You get 15 is equal to 1/2 X. Multiply both sides by 2, and X is equal to 30. 30 degrees. For number 4, we know that since this is an outside one, we have to take the difference of those two and subtract them. That's what the difference is, and take half of that. So X minus 40 times 1/2 is equal to my 20. I'm going to go ahead and multiply both sides by 2. That gives me X minus 40 is equal to 40. Add 40 to both sides. X is equal to 80 degrees. For number 5, they didn't tell you what this was, but they don't have to tell you what that is because they did tell you this was 150, and this has to be all the rest of it. So that's just going to be 360 degrees around minus the 150 gives you 210 degrees. So X is going to be the 210 degrees. They didn't ask you anything about that. They weren't worried about the measure of the angle. Trick question, but it's there. For number 6, it would be 1/2 of 150 minus X equals 50. Go ahead and multiply both sides by 2. 150 minus X equals 100. And you end up with subtracting 150 from both sides. And you get negative X is equal to negative 50. So X must be 50. Hey, look, I was right on that one too. I did good on this. I bet you can too. Now, these 6 problems, they were the classwork. Just letting you know now. They were the classwork. So your classwork has been done. Your homework, however, has not. It is on page 375. It is the practice exercises, numbers 1, 3, and 5. Just 3 of them. You can handle that. And you'll see me probably tomorrow. Bye.